George Bullen is an internationally recognized expert and consultant to industry for the manufacture of fixed and rotary wing aircraft, rockets, missiles, and space vehicles. He's been awarded 16 US and international patents. He's a fellow of the Society of Manufacturing Engineers and certified in production and inventory control management. He has an MBA from Loyola Marymount University and a BSMG degree from Pepperdine. He's received the SAE International's Forrest McFarland Award, the American Institute of Aeronautics and Astronautics Design Engineering Award, and the 2019 SAE AIAA William Little Memorial Lecturer Award. It is my pleasure to welcome Nick Bullen and his panel, Cyber Physical for Additive Manufacturing. Thank you very much, and have a great AeroDef.
Good morning. Okay, I'm married to a school teacher. You've got to do better than that. Okay, good morning. There it is. All right. As I mentioned, these are my panelists who are going to come up on stage. I was hoping they would join me up on stage. Come on up here. We have a distinguished panel. Brent Brunel, Senior Executive Additive Technology Leader for GE Global Research. Eric Fodron, who I work with and consider to be an expert in additive manufacturing, Global Ops Manufacturing Technology Development for Northrop Grumman Corporation. Stephen Thomas, Co-Founder and Chief Strategy Officer for Identify 3D, and Mark, and Mark, cheers. I'm just going to call you Mark, okay? Would brutalize your last name, Assistant Professor, University of South Alabama. What we're focused here on is additive manufacturing and art to part, and cybersecurity as it applies that specific type of technology and the relevance it has to impact to our defense manufacturing community. Get started here. What you see there is an additive part. A lot of people don't realize that when you read in the newspaper, you would think additive was very simple. All you do is get a machine and you print something out and done, one and done. It's not quite that easy. The benefits to the aerospace industry are many. One of them is that you can take very complex collection of assemblies, combine them into a part, make them lighter weight, but there's a lot of nuances that go into creating an additive part for a flyaway type of product. There's a lot of issues with that. If you look at this one was courtesy of Airbus. They're very lightweight, they're very sophisticated, and they draw us to them because of the ability to combine parts without having to do assembly and complex tooling and machining.
You're Ohio and Pennsylvania.
Boop. Let's do this.
Fair amount of material science.
That's a neural network. That's Facebook's neural network. There's good and bad to that. If you have a phone now and you have it turned off, Facebook has the capability of turning your microphone on and listening to what you're saying. They have advanced analytics that can analyze what you're saying, and then if you go to Facebook and call up, if you have a Facebook account or a LinkedIn account or a Google account, you'll suddenly notice that what you were talking about, that item that you were talking about, will appear in a banner next to your name. That's powerful stuff. Very powerful stuff. It's good and it's bad. It's bad because it's intrusive. It's good because it provides us with power to distribute things across our enterprise, our global manufacturing enterprise, very rapidly. We want that within our factories. We want to be able to communicate across the digital thread so we can optimize our productivity and use the digital thread and the Internet of Things in order to optimize what we do. But we don't want to have somebody intrude into our business, into our product in order to defeat what we're doing. If you take it out, and Kevin mentioned this earlier about the complex interdependencies across the supply chain, we no longer live in a centric manufacturing society isolated within the United States. It's a global manufacturing conglomerate that brings things together into assembly centers that is dependent upon the digital thread in order to optimize our productivity. The problem is that it's not hard to hack into that and do damage anywhere along that supply chain. If you look at this, it says high school students hack school system to change grades and attendance. Now, my wife, I mentioned, was a school teacher. When I showed her this, her argument was if they'd spent 10% of the time that they took to hack into the system, they probably could have gotten better grades than just going in and changing their grades. But the perception is that our adversaries want to steal our stuff, and they do. They really do. But there's a greater danger we want to talk about here. One of the things that they can do when they hack into our systems, especially when we have something so close together as art to part, and I know that's a cliche, but one of the things they can do is they can create structural damage that doesn't manifest itself until the flight article is stressed, and then you can get catastrophic failure. The young lady and her team who died in that crash up at, off of Whidbey Island was flying a mission, and her planes, one of the spars cracked and she crashed, and all of the crew members were killed. Now that wasn't necessarily from a cyber attack, but you can see where a critical component on an aircraft, the failure of a critical component on an aircraft at a very critical time in the flight regime can cause failure of the aircraft, catastrophic aircraft. Nor does your adversary have to hack into your system and create some type of a defect in your part on every part. They can randomly select a part so that everyone knows the story of the 737 MAX, where a couple failures and that aircraft grounded every aircraft. If they want to ground your aircraft, if they want to do damage to you, they don't need to damage every part on every aircraft. They only need to damage certain parts on certain aircraft, randomly applied, so that you don't have confidence in the flight of that aircraft or the capability of that aircraft anymore. So we want to get rid of the bugs. One of the things we want to do today, and I'm going to introduce, I want to introduce a video here shortly that'll give you an idea of what that kind of thing, when we introduce those kinds of failures into the system, what can happen. Mark has a video, and if you could cue the video up here, I'd like to show Mark's video very quickly. So let's get started. as I said, you don't have to introduce failure into every part. You don't need to have catastrophic failure of every one of your parts within any number of aircraft. Just randomly give a lack of confidence to the operator of the product so that they can no longer operate their product. Scary stuff, right? Especially since you're going so short of a stroke from art to part. So I want to take a second to let each of the panelists introduce themselves, a short introduction, and give their impression of what we can do to cyber protect ourselves from these types of attacks in the additive manufacturing field. First, Brent Brunel, Senior Executive from Additive Technology Leader for GE Global Research. Would you like to say a few words?
Yeah, great, yes. Thank you, Nick, very much. Yeah, so I guess first, my name is Brent Brunel, so I run the Additive Technology Research at GE Research Center. Hey, at our place, we've been trying to figure out what is the critical area to look at for security from an additive manufacturer point of view. And where we've come down to is the control system on our machines is a critical point. So our keynote speaker before he talked about what he was hitting at was he was worried that, hey, when somebody got into our machines, what would happen at that point? I don't know if do you have the slide at all, Nick, or is that not up there?
No, sorry.
Okay, no problem. Right, great. So, hey, what we've been focusing on at the research center is how can we make it so that our machines are locked down, locked tight, and that nobody can change the hardware, the software, or any applications on top of it. We've been focusing on is how do I build that chain of trust? Trust is the most important part of this entire security play. What we're using as our key of trust is a trusted platform module built into the controls box. That's our trusted, holder, a trusted place for all our keys and all our security pieces. What we've done is built up off of that trust layers of security, so our trusted boot, trusted operating system through every single layer. So that if anybody tries to change a single bit of software, then we can detect it, and then we can do the right kind of accommodation for that. Relative to the problem that Mark brought up with that great video, what we're looking at is from that point down, so from the design file out to the machine. All right, so what we want to do is use that same root of trust. Inside that, we have our lockdown keys, lockdown characteristics. Want to be able to do a public-private key, put that onto the part that we're shipping across, and only be able to unlock it on that particular machine. All right, so now I know that machine, I trust that machine. This is a certified part that's coming across. We want to build off of that system to build our security. So, and for us, Nick, we're trying to apply that across our entire portfolio of products. So we have our metal additive products, we have our E-beam, our DMLM, our laser-based, and also we just introduced our binder jet machines. So we're trying to take that same architecture across all of our machines is where we're trying to go.
Thank you. Brent.
Awesome, Brett.
Next is Eric Fodrin. Eric, can you do a little introduction of yourself and tell me why you think, or all of us, why you think cybersecurity is important in additive?
Of course. Eric Fodrin. I'm also within Northrop Grumman. I'm the focal point for materials and process development for the Manufacturing Technology Development Organization for the AS sector. Predominantly focused towards additive manufacturing for the past probably decade, if not more. From the standpoint of why do I think it's important, the threat surface which additive manufacturing contributes to has grown considerably over the past 5 to 10 years. So that means the opportunities for intrusion has grown immensely, and as was discussed previously, those who are targeting us have grown considerably as well. In previous times, it was just a singularity, but now it's a multitude of individuals and countries looking to attain either defense data or proprietary data for profit. So, what are we at Northrop Grumman predominantly interested in? I would say we realize that the majority of the platforms you see on the floor today, unlike what Brent has described, they're produced or they're manufactured for producibility, not necessarily for security. They're also manufactured for longevity. And unlike a server system that we might replace every couple of years to update a level of security. The level of security that you attain in one of these, let's say a new machine, that's going to become obsolete very soon. Hopefully the majority of the additive manufacturing community is going to adopt the same type of protocols that GE is. But until then, two of the things that Northrop Grumman is interested in exploring is the opportunity to look at in situ monitoring such that we can understand if in fact defects are being implemented into any file and resulting into anomalies or discontinuities, which can be very hard to identify through standard non-destructive evaluation practices. So that is one means, and another means that is a very interesting interest to us is software and technology bases that can evaluate the STLs, the AMF files that are being fed into the machines, such that it, hopefully, with the addition of what GE is pursuing, that has a better complement together to control and exclude the type of anomalies that we believe can be threatening in the future.
Thank you, Eric. Stefan, same question, co-founder and chief strategy officer for Identity 3D.
Good morning. So Identify 3D develops software solution for digital manufacturing, so additive manufacturing, but also subtractive manufacturing. And our software protects, manage the usage and the traceability of manufacturing data, engineering data, design data from CAD, CAM, PLM, all the way down to the machine itself, like SLM solutions, for example. There's great benefits with additive manufacturing. I mean, this is a technology that is in development. One of the promise of that technology is the ability to, at one point, one day, to be able to manufacture where you want and when you want, the true decentralized manufacturing. So what that means is that instead of moving boxes, instead of moving parts, we will be moving data. And that's where there is a huge risk associated with the control of those data, especially when they move between systems, from a PLM to another, but also from platform to another, or from a supplier to another. All of those create weak points where those data can be intercepted, manipulated, so to dangerous outcome. So a combination of IP theft, but also malicious intent over those data. So we hope our software will help mitigate some of that risk.
Thank you. And your next, Mark, University of South Alabama assistant professor.
Yeah, okay. As a professor, I'm looking always for some new research questions and also new solutions and problems. And I think that additive manufacturing security is way more complex than just cybersecurity or cyber-physical system security. I think that it is essential, and this is important to emphasize, that what my panelists are doing, it is essential, it is necessary. I just think that we have to think a little bit broader and think about cyber-physical impacts or physical-to-physical impacts. And this is something what many people, I'm sorry, don't realize or try to pretend that doesn't exist, that you can impact the quality of a part by manipulating your feedstock like powder. You can do the same manipulating power supply to the machines or similar. So these are things that cannot be right now caught by cyber only. So we have to, on top of cyber solutions that are extremely essential, and I want to emphasize this, on top of this, we need to build additional solutions that will catch also attacks that bypass cyber. Yeah.
Thank you. Do we have any questions? This is an informal. This is not us talking to you, but a dialogue that has to take place between the audience and the panelists. So I just don't want to lock this down so that we feed information going that way. Does anyone have any questions or anything you'd like to ask? Or let's start a dialogue here. Yes, sir.
I was wondering if blockchain is in the equation. There are people that are for it. There are people that are against it, for ecology, for possible hijacking by other countries, by quantum computing? What's your take on blockchain, and if not, what do we use?
I can start about blockchain. So we've done some work with blockchain. We won't define ourselves as a blockchain company. We are blockchain enabled. We need to have the right case study for that. I think this is still a technology that's looking for the right case study. There's element of application, definitely, in the supply chain, but it's not an end to all. It's what is your case study? What is it that the blockchain technology will bring that a centralized solution will not, and vice versa. So as such, we're working with different customers to evaluate those use case, if you will, and then see whether blockchain is the right one or not.
I'd like to do something. Would one of the panelists like to take a shot at defining blockchain for those who don't know what blockchain is?
How about the computer scientist at the end here?
Okay, but basically you have a ledger of information that is signed by one party, and you add additional part by other party, and this party adds signature over the entire chain, and you can basically increase information, and you have different pieces signed by multiple parties. Is it enough as explanation?
Oh,
okay. Okay, if I may add to this, I think that the danger with blockchain is that right now it is a hype, and because it is hype, people try to apply it everywhere. I think that there are different, some specific applications where blockchain makes absolutely sense, but there are other applications where it doesn't. And just one of critique points, just think about the fact that the validity of the data depends on the information that somebody is providing to this blockchain. So if you have malicious actors who are providing false information into blockchain, they have a problem. Yeah.
Can I ask your question?
If I may just say one other additional thing is, like my colleague and CEO of Identify 3D will actually do a talk specifically on blockchain and the digital thread at 10:30 in room 202. So if you want to know more about that, you'll get to hear more about that.
Oh, 10:30 in room 202?
202, yeah, I believe.
202?
It's in
Yes.
the program.
You have a question?
Nick.
Over here first.
Oh, I'm right here?
All right.
Sorry.
So we see that each of you have identified a specific way that you're attacking the cybersecurity issue. When we look at the supply chain, we obviously are going to have to look at some standards and ways that we can come up with just standardized ways of handling cybersecurity. So do you see standards playing a significant role in this, and how so?
Yep. So, yeah, I can kick off on that. So, yeah, from our side, what we're seeing is, hey, we like the overarching IEC 62443. That's a great guideline for us to give. Hey, here's our target on where we want to go to. But the general issue we're seeing in the additive manufacturing is there's not a targeted additive manufacturing security standard. And then on the bottom side, maybe we're seeing TCG doing some great work on TPM 2.0, on trusted certificates for the platform, but there's still not that, hey, from chip out to vendor and out to the customers, how does that entire system work? There's not a standard at all for that. So that it just leaves the user base, the entire industry, working at their own different solutions. So until we get to a standard for parts of that, it's going to take us longer, it's going to slow us down from getting to where we need to be overall.
Now let me address that a little bit. Deputy Director Baldwin, Strategic Technology, Protection and Exploitation for the Office of the Secretary of Defense, that's a title, is actually led a bunch of representatives from the defense, commercial, and defense industry. Boeing is a member of that panel, Airbus, Lockheed, Honeywell, Collins Aerospace, Raytheon, Intel, IBM, and the Department of Defense. They're forming a panel in order for cyber physical system security, CPSS, in order to identify protocols and standards for industry. so that somebody could look at what protocols and standards we can use in order to protect the additive manufacturing as well as cybersecurity threats against other products and technologies. So there is a move on the part of the United States government in order to, they recognize there needs to be a standard. They recognize there need to be protocols. They recognize that the industry has to have something they can go to in order to understand what they need to do in order to protect the product that they're producing. Yes? The microphone, I'm sorry, the mic is
So the question is, the macro trend is how do we drive cost out of the manufacturing process? And that's going across the supply chain. Security generally tends to be a cost center. So I'd be very interested in your respective perspectives on when I'm making a business case, what do I say beyond the fact of innovate or die? We need to do this to be able to participate in this particular thread of the supply chain. How can I use these security technologies to drive cost out of my process so that it's not just going to my overhead and allowing me to build it into my supply chain?
I think let me see if I can paraphrase your question so that I understand it. You're saying that there is a cost to cybersecurity, and that cost has to be built into the product. How do I mitigate that cost along my supply chain to keep my price competitive? Is that correct? Is that what you're saying? And I mean this, I don't mean this facetiously to ask Boeing about that. I mean, imagine and cybersecurity didn't cause the accident with the 737 MAX, but the failure of a component, not caused by at least I don't think it was, caused by cybersecurity, grounded their entire fleet, billions of dollars, because somebody wanted to save some money. So what's the cost? If somebody were to hack in along the supply chain to cause failure in your aircraft, Boeing's paying the cost for something that, and I'm not judging Boeing. I mean, we all have our own issues, right? But I'm saying that whole fleet of aircraft is costing them billions of dollars, where probably a few $1,000s would have prevented that. Am I right or wrong? So my answer is that cybersecurity is an essential component of the cost of us producing something that gives us reliability so that we don't have to bite that bullet in the performance of our aircraft. Arguably, an airplane is the most complex machine built by human beings in a production environment, operating in the most extreme environments. And it's still the safest form and method of transportation.
Yeah, so.
But do you want to risk that with a new technology without making sure that it's secure along your supply chain? So anybody else would like to chime in there?
I would say that it is cybersecurity itself, and the cost associated with that is an inherent entity within the system. And maybe the analogy that is oversimplified but makes sense to me in some regard is I look at cybersecurity and security measures as a whole as let's say similar to a brake system in your car. You don't necessarily have brakes so you can stop, but you have brakes so you can have that security in moving forward and moving fast. And I believe that's what we need to ensure within the additive manufacturing realm or the manufacturing realm as a whole. And honestly, from our perspective, there's going to be so many facets of that. We're only touching a portion of them. As you described, it's a complementary portion, and we're hoping that the community as a whole will work more collectively and hopefully develop standards in that regard. And unfortunately, I believe that's still in the distant future. But I think discussions like these will hopefully promote that further. I don't know if the currently government-centric set of standards is really impactful to us yet, but I am hopeful that it will be soon. And I think private party, public-private party partnerships such as those which you're leading, Ralph, can be a good portion of how to drive that. Good entities and strong abilities to say these are the standards that really make the most sense to us. And I think in some of the projects they're already doing that, which is a good thing. But in short, I have to somewhat parrot Nick's response, and it's just an inherent cost that I think we're going to have to develop and digest. And then at some point, I think that becomes a little more tolerable on a regular basis. But until that comes, I'm not really sure how to mitigate that per se.
Yep. Yeah, so great question. Maybe there's two other ways to look at it. So one is, hey, that a lot of the cybersecurity technologies themselves are relatively cheap. But like this TPM is $1 chip, $1 or $2, right, for that chip. Building the software stack off of it, different companies are starting to build that already. So getting those pieces tied together, right, shouldn't be overall that costly. The other part is the cyber physical that Mark hit on, right, is that what we're seeing is this tie between the security and the physical side. So if you talk about integrity of the part, right, there's hey, is the file the correct file? Is this a trusted machine to go put it on? But there's also the monitoring side of that. So I can put measure sensors in to make sure that nothing bad happened while they were actually building that part in the middle of that thing. So it starts to bring performance and monitoring as well. That's some benefit. Maybe that starts to get its way to buy some of the cybersecurity features onto the machine.
And just a quick analogy I want to make. Security, it's like insurance. You don't like buying insurance because you're betting against something that you don't want to happen, but if you want to have the benefits of the insurance, it needs to happen. And sometimes we bet on our house, on our car, on our life, actually. So we see security as something very similar. It's really the cost of not doing it that could be huge. And then every risk that we look at in the manufacturing or generally in the business, it's always a relationship between what is the probability of that risk and what is the impact of that risk. And then when we map that, then we have to focus first on, well, the biggest impact and the biggest probability.
And if I may add very, very short, actually, to those points, it is also the question about liability and cost-benefit analysis. So if we become aware about liability for negligence of, for instance, for somebody introducing flaw in the part, and how much it will cost, then companies will be motivated to make other insurance policy investment into security by TPM modules or software solutions, etc. Yeah.
I think I think it also drives down through the supply chain from an OEM. I think what you look at is not just that person who's producing the part, their cybersecurity, whether they think they're secure, but as a person who's going to buy that product from them and put it in our airplane, how do I know that what you're doing is secure? How do I validate your security system in order to understand that what you're providing me really is what you think you're giving me, right? It goes deeper than just your security, but how do you assure me that that's been done? So anyone else? Yeah, you got the mic.
My name is Evan Partalis. I represent Klockner Metals. We're an international company. We do about $3.5 billion in Europe and $3.5 billion in North America and split around the rest of the world. What specific cyber threats do you see in terms of an international company when you have all these different kind of inputs and suppliers? Somebody could screw up the mill process, for example, at an aluminum mill or a steel mill, and the heat number would be fine and we would get the material. It would be all traceable, but there could be some defects in it. How do you mitigate, I guess, cybersecurity with a company that involves a lot of partners like that with a complicated supply chain? Maybe it's a difficult question. I don't know.
No, I think you're talking about material properties, the material that feeds the 3D process. Is that what you're speaking of more? Okay, so, and it's a good point. I mean, we're not just talking about protecting the product and the file that you're using to print, but the material that feeds the machine, right? I think that's what we're talking about. And it's a very important component of cybersecurity. It isn't just point of use, it's everything that comes before and everything that comes afterwards. So does anyone want to address that?
Yeah, okay. I will try to provide a broad picture. Obviously, we have to secure the entire additive manufacturing workflow. It is not only about securing the 3D printer itself, it is about securing pretty much everything. And it opens up a very complex situation when we have to care about cybersecurity, cyber-physical security, physical security. And we have to think about not only one threat, but different security threats. Okay, like in the video, it is sabotage attacks. Like Stefan has mentioned, it is theft of intellectual property or theft of technical data. And there is a third threat emerging right now is misuse of additive to manufacture illegal parts. Think about plastic guns, components of explosive devices, or maybe to bypass nuclear non-proliferation treaty. All this is a very complex situation with very complex workflow that can be misused or attacked, and also with 3 different threat categories. And yeah.
Yeah. I wanted to say some of the similar thing. It's about protecting the entire ecosystems when it starts from material all the way to the physical life of the end part, and connecting all that information together in what I think Mr. Mitchell defined earlier as the digital thread. So ultimately, that's what we want to be able to accomplish. There are also companies that are specialized in actually tracing the DNA of the material. So it's part of, there is solutions out there that needs to be integrated into the broader ecosystem.
Yeah, that monitor the entire complex interdependencies all the way from the material through the part utilization, right? Is that what you're saying?
Yep.
Yeah. Real quickly, my daughter's one of the leading DoD cybersecurity experts, worked for Global Strike and is now at Wright-Patterson Air Force Base, research directorate. And she was talking to me the other day when I told her I was going to do this panel. She said, we used to use the philosophy of detect and defend. She says, we're starting to develop a philosophy, detect, defend, and then attack. What we're doing is, if you don't send a message back to those people who are trying to come and hack into your system and do damage to you, you need to send a very positive message back to them that if you attack us, you're going to be attacked back. And as long as you're in a defensive mode in cybersecurity, you end up eventually somebody's going to get into your system, somebody's going to do damage. But if you, every time somebody tries to, you detect somebody coming into your system, you defend against it, and you send a message back, and it's a strong message that damages whatever system they're using in order to attack your system, that sends a stronger message than just, I've defeated your attack against my system. So that's one of the new cybersecurity methodologies they're using in the Department of Defense in order to go back at those people who try to attack you, attack back. So anyway, yes, any other questions? Who has the microphone? There you go.
And this will be our last question.
Jim Novak of Talent Swarm. Mike, nobody would get on a plane whose pilot had not gone through a simulator. Likewise, I'm thinking in these complex cyber systems that we're designing, the airplanes, they're such complex machines. Why not follow the process of creating a digital twin of that plane so that a black box up in the cloud would have been the 737, and maybe thousands of flight simulator players would have found that error before the pilots had crashed.
Awesome.
And that's a way of crowdsourcing a lot of people without giving away any intellectual property, but you create a digital twin that's going to behave as close as possible to the real thing, and we use thousands of volunteers to find problems before they cause deaths.
Awesome. Yeah.
Want to address that?
I got to jump on that one. So perfect. Thank you very much. I'd say we've been looking at exactly that idea. We call it digital ghost, and the idea is, hey, how do I build up a physical model of the system, play it through all the different, corner cases, attack vectors, and try to figure out based off of that. So large computing, large AI, not the crowdsourcing part, but that's a great idea. To figure out, hey, this is how I can detect those. This is how I can accommodate those. And I haven't gone back to the attacking back, but that's a great idea. But we're going to have a session on Digital Ghost. Is at 10:30 in room 202, so I'd love to talk to you about Digital Ghost, so it'll be great. Yep.
Eric?
I would say from a Northrop Grumman perspective, we're definitely employing the digital thread, digital twin perspective. We have not moved forward for the crowdsourcing opportunity given the sensitivity of our product, but I could definitely see how that could tend to a much more rapid response and understanding of some of the challenges, but I do believe there is a lot of value in the twin thread moving forward in the manufacturing environment and controlling what is being manufactured, understanding what is being manufactured, and how that relates to an overall life cycle and sustainment.
I think it's a great idea, probably not easy to implement, but definitely there will be need to be secure too. So.
I just would caution, I think it can help a lot, but I would really suggest a big caution because attackers are very creative. And they always come with new ways to attack systems and bypass security measures. Therefore, we shouldn't be complacent if we develop digital twin or digital ghost and it provides us that system is secure. Okay, it is semi-definite answer. Okay, it can only answer that it is secure against threats that we are aware and tested it against. Yeah.
I can one last thing, and then I'll get off the stage. I can tell you in DoD, there's two offices, two buildings. One is meant for defense. They're constantly monitoring to see if we're being attacked and what the venue and avenue of that attack is coming from. There's another building populated with people who play game theory. They're in there trying to attack our own system. So we can actively participate in a defensive measure with really bright people who are saying, I'm going to try and go in, and now it's passive. They're not necessarily going to damage anything, but they're constantly looking at our defensive measures and attacking it in different ways and saying, how would a hacker go in and do this? That's a great way for us to develop attack or defend and attack type of a proposition for cybersecurity. Anyway, thank you for your time. I know we've gone over a little bit, but thank you for your time being patient. And I'd like to thank all our panelists. Thank you very much.